Hey folks, Rick here from the LaLa Farm. Today we're going to talk about soil. Just kidding. Talking about soil pH. Hey folks, good morning. So today we're going to talk about it's an really important topic, but not one that gets a lot of airtime, particularly with respect to your garden. We're going to talk about soil pH. In simplest terms.
Yeah, I don't know if it's simple or not, because I took chemistry. It's the only course I ever dropped out of in high school and changed to something easier.
In simplest terms, pH is a scale used to determine the level of acidity or alkalinity of a solution. A pH of 7 is considered neutral, whereas a pH less than 7 is generally considered acidic, and a pH over 7 is considered to be alkaline. So as we go about this and we talk about this topic of soil pH, put down in the comment section below, how do you check your pH, if you even do check your pH, or, do you know what your soil pH is, and do you think it might be a good idea to check it? Put that down in the comment section below. I'd like to hear your thoughts on that. The pH of your soil, meaning the alkalinity or the acidity, can impact the nutrient availability that your plants have for uptaking those nutrients or absorbing those nutrients through the root system. So here I have a basic chart. This is one that I've referenced in the past, not just with respect to gardening, but with respect to other issues when I'm trying to adjust the pH of something, maybe something in the shop. But this chart basically shows, from a soil angle, roughly the sweet spot for pH range. So roughly speaking, it's between, this chart says 6.2 to 7.3. Generally speaking, it's between 6 and about 7.5. And you can see within that pH range right here is the greatest amount of uptake of nutrients. You can see as the pH goes lower, it becomes more acidic, the availability of things such as nitrogen, phosphorus, potassium. Those are the NPK, the three big things in gardening that you want, the three big macronutrients that you want taken up by your plants. As the pH lowers, the availability of those nutrients becomes less and less to the plant. So if you look here, within this box is the greatest amount of green for all of the macro and micronutrients. So this is why soil pH is really important, is it opens up the availability or allows for the availability of more nutrients to the plant. So depending upon where you live in the United States, or the world for that matter, geographically, the pH of the soil in a region or even a locality can vary widely. Take a look at this chart from the National Geological Survey. So you can see the further east that you move, the more acidic, meaning the lower the pH the soil becomes, whereas the further west, generally speaking, the soil becomes more alkaline. Now there's pockets up in the northwest has acidic soil, but the mountainous regions, kind of the plains area, deserts, are much more alkaline, generally speaking. So having a soil that is either more alkaline or more acidic does not necessarily mean that that's a bad thing. It really depends upon what you're growing. Some plants prefer more acidic soil, such as blueberries and some fruits, prefer more acidic soil. Whereas some plants, watermelons, for example, are much more adaptable to a wider range of pH values. It's very rare that you're going to have to know the exact pH of your soil. What's more importantly is that you know that the pH of your soil is within that sweet spot. Generally speaking, between 6 and 7.5. With some exceptions, it may be a little bit lower, again, depending upon what you're growing. Some flowers and other garden plants, rhododendrons, for example, a little bit more acidic soil. But generally speaking, most plants can adapt within that 6 to 7.5 range. So there's multiple ways that you can check what the pH is in your soil. Most places in the United States, or at least that I'm aware of, I know in our county and throughout Florida and the Southeast, there are agricultural extension offices that are affiliated with universities. In Florida, it is the University of Florida Institute for Agricultural Studies. So each county has their own agricultural extension office, and you can take soil samples into the agricultural extension office. They'll test it generally between $5 and $10 per sample, and that will give you a very analytical, detailed printout of all of the macro, micronutrients, and the pH of your soil. I've seen those reports before, and kind of they're hard to read. You're not really sure what you're looking for. So you generally have to call them, ask them what's going on with a soil sample, and then they can kind of explain it to you. But that it's taken as long as 10 days, 15 days or so. So it's not something that you're going to get an immediate response to. Now there's also soil quick tests that you can do. So I've got a couple of here. Here's one. This is a soil pH test strip. I got these on Amazon just to try them and to make sure to validate that this whole process that I'm going to go through today works. So this is a soil pH test strip off of Amazon. I think I paid $12 for this little bottle. There's, I think, 100 strips in here. And it'll kind of get you into the ballpark. You'll see that it's just the whole numbers from 0 to 14, and you're looking for the color strip to kind of match in here. And again, we're looking for soils between 6 and 7.5. You'll notice this does not have decimal points. Here's another instrument. You know, I got this, I've had this. I don't think this works particularly well. I do use it for moisture, but this is a three-way tester that looks at light, pH, and moisture. Now I know that our soil is pretty neutral, so it's around a 7 here on the farm. Now if I use this to check the alkalinity, I come up with about an 8. So this is really not calibrated well, and I would not recommend using this type of instrument. Although, you know, every time I say I wouldn't recommend, there's going to be people in the comments that say,
"No, you're doing it all wrong. You need to do this, that, and the other thing."
It's my personal preference that I don't use that instrument for checking pH. I mean, I pretty much know what our soil is, so I don't go checking pH regularly. I do check pH when I'm recycling soil, though, to make sure that any amendments that I've put into the soil have not lowered or increased the pH value of the soil higher than I want it, so then I can adjust it by adding amendments, whether that be sulfur or limestone, to move the pH up or down. So that's a whole other topic. So fortunately, there's a really quick, easy, and fun way to kind of get a basic idea of where your soil pH is. If it's in that sweet spot or very close to that sweet spot of between 6 and 7.5, using just regular kitchen household goods. So at some point during your education, you probably had some exposure to soil alkalinity and acidity by using a demonstration where they combine two ingredients and it makes an explosion, usually like a volcano or something like that. Very early in science, usually around middle school is when that exposure will happen. We're going to use that science to do this today. What we're talking about is a chemical reaction. When we take a substance that is either highly acidic or highly alkaline, and then we add it to the opposite. We add it to something else that is either acidic or alkaline, we get a chemical reaction. And that's really what we're going to be doing to test for soil pH. Let's take this cup. I'm going to add to that a little bit of vinegar. Now vinegar has a pH of about 2, so it is more on the acidic side of the pH continuum. And I'm going to then take some regular old, I've put some water in this, put it into a suspension, and it's settled out. So I'm going to stir this. But this is nothing more than just household baking soda. Now baking soda has a pH of about 9. Okay, so I'm going to take a substance, baking soda, has a pH of about 9, and I'm going to add it to the vinegar, which has a pH of about 2. Just 1 little tablespoon. And that's what happens. So there's a chemical reaction that happens when you take a highly acidic substance and you add to it a highly alkaline substance. we're going to use that same principle to show pH of your soil. So what I've got here are 2 dishes of soil that I've dug up today. Put them into the dish, kind of equally divided them here. I'm going to add some water. Now I'm using distilled water. So why distilled water? Why is that important? Why can't you just use tap water? We're on a well. In our water, I know we have high levels of calcium, lime, and sulfur. Now if you're on well water, many municipalities will treat with chlorine. So all of those chemicals that are added to the water have certain pH levels themselves that can either higher or increase or decrease the pH of the soil. Distilled water is exactly that. It is basically condensation from boiled off water. So that's what we're going to be using, is distilled water. So we're just going to pour this in so that it covers up the soil. Now distilled water, perfect water, is neutral, meaning it has a pH level of 7. Okay, so hold that thought. I got to rinse off. Got to get me a spoon. I was going to put my baking soda spoon in there, which would have contaminated this. So we're just going to stir this up to be able to put that dirt into what's called a suspension, meaning that it's floating in the water. Now it's going to settle out, but there's going to be some very fine particulates still floating in the water. So now we've got our dirt. We've added some distilled water to that's in suspension. So now what we're going to do is we're simply going to add a base substance, or I'm sorry, an alkaline substance to one of these, and we're going to add the acidic substance to the other and look for a chemical reaction. So whichever one, if either, gets a chemical reaction, then that will kind of tell us whether the soil is more alkaline or more acidic. Let's start with the baking soda. So the baking soda, recall, has a pH of around 9. And let's add that to this one. So I stirred it up. And we're just going to pour it in there. And we're going to look for a fizzing chemical reaction. And we're not really seeing anything. The bubbles here is where I poured it in. So there might be a little tiny bit of reaction, but nothing significant. Alright, now let's go with the vinegar. So had I gotten a reaction here, then what that would suggest is that our soil was, because I'm pouring an alkaline substance into it, was more acidic. There's no reaction there, a very minor reaction. Nothing like we did when we poured it into this cup. Now I'm going to take the vinegar, which is a acidic substance, and I'm going to pour it in. So if we get a reaction this way, then that tells us that the soil is more alkaline. And there we get absolutely no reaction. So if anything, what we can conclude is we got no reaction to the one where we're adding the alkaline, and we got no reaction to the one, we got a little bit when we're adding the alkaline, which means it might slightly be on the acidic side. We got nothing when we poured the one in that would tell us that it's alkaline. Okay, so no reaction really on either one. What that tells us is that this soil is very, very close to being neutral. Now I did use this test strip and to verify kind of what our soil was probably several weeks ago, and we're about, I would say, between a 6 and a 7. You know, we're using these color strips here, so they're not perfect, but between a 6 and a 7, which is exactly what we're getting by using this test, using basic chemistry to determine whether we get a reaction to the vinegar or to the baking soda. So by not getting a reaction to either one of these bowls of soil, what that essentially is telling us is that we're very close to a neutral soil, slightly acidic maybe. That falls well within that range that we're talking about, from about a 6 to a 7.5. So most plants are going to adapt well to the soil. Now this is not telling us about organic matter in the soil. It's literally just telling us the acidity of the soil, or the alkalinity, or the pH of the soil. The more or the closer that the pH is to that sweet spot, that 6 to 7.5, the greater the availability of nutrients will be to the plants that are growing in that soil. So very rarely, as I said earlier, is the question, I want to know whether my pH is a 4.2 or a 6.7. It's not that specific when it comes to gardening. There's a range that you want it to be in, so we're really kind of just trying to narrow it down to make sure the soil is roughly where we want it. It's not a high degree of precision, which is why this method is perfectly adequate for measuring the pH of your soil. If you like specificity, if you like absolute values, then maybe you shouldn't use this. Maybe you should go and pull a soil sample, send it to your extension office, and you can get a full and detailed report of your soil pH and all the macro and micronutrients that are in that soil. And if that's your preference, then go ahead and do that. For our purposes, all I'm looking for is pH. This method works perfectly well for me. So folks, always remember, treat others as you would like to be treated. Here's hoping for no chemical overreactions in your soil.